Yes, welcome. We are going to be continuing with the laboratory preparation of ammonia. Ammonia is prepared in the lab by heating an ammonium compound, e.g., ammonium chloride, with a cheap base like slaked lime, which is calcium hydroxide. The gas is collected by upward delivery and dried by an unusual drying agent, quicklime, CaO. Quicklime is used because it reacts with all the usual drying agents. Concentrated tetraoxosulfate 6 is acid and would absorb the gas, forming a salt. So you use quicklime because ammonia reacts with other drying agents. So it's better you use quicklime because that's the only substance that it wouldn't react with. Ammonia also reacts with calcium chloride, forming solid complex compounds. So you cannot use any of these as the drying agent. You just have to use quicklime in the laboratory preparation of ammonia as the drying agent. Now let's look at the physical properties of ammonia. Ammonia is a colorless gas with a choking smell. It is an alkaline gas, changing moist red litmus paper blue. It is about 7 times less dense than air. Ammonia is the most soluble gas. That is why it cannot be collected over water. The solubility can be demonstrated with the fountain experiment. Ammonia has a boiling point of minus 7.7 degrees Celsius and a melting point of minus 34.4 degrees Celsius. Chemical properties of ammonia. Reaction with oxygen. Ammonia does not normally burn in air, but it burns in air that is enriched with oxygen to form nitrogen and water. In the presence of heated platinum catalyst, ammonia reacts with excess air to produce nitrogen 2 oxide. As a reducing agent, reducing power of ammonia. Ammonia is a good reducing agent, and that means it can be easily oxidized. It reduces copper 2 oxide to copper. Now let's look at the uses of ammonia. Ammonia solution is used in laundry work. It removes temporary hardness by precipitating the calcium ion of calcium hydrogen triisocarbonate 4 as chalk. Ammonia is used to make nitrogenous fertilizers such as ammonium tetraoxosulfate 6 and ammonium triisonitrate 5 salts. It can be used as a cleaning agent. Liquefied ammonia is used as the working gas in refrigerators. In the solvay process, it is one of the most important components for the manufacture of washing soda. Oxides of nitrogen. Nitrogen forms several oxides, of which the most common ones are dinitrogen 1 oxide, which is a colorless gas. It is prepared by heating any mixture, which by double decomposition will yield ammonium triisonitrate 5. Example is a mixture of potassium triisonitrate 5 and ammonium tetraoxosulfate 6. Physical properties of dinitrogen 1 oxide. Dinitrogen 1 oxide is a colorless gas with a slightly sweet smell. The gas is slightly soluble in water. It is neutral to most litmus paper. It is slightly denser than air. It can be liquefied. It is known as a laughing gas because it causes uncontrollable fits of laughter when inhaled. So the gas known as laughing gas is dinitrogen 1 oxide. Very, very important. You need to take note. Chemical properties of dinitrogen 1 oxide. Action of heat. Dinitrogen 1 oxide decomposes into nitrogen and oxygen at 500 degrees Celsius. And so only a bright glowing splint, hot enough, relights it. It easily oxidizes to the following strongly burning elements to their oxides: magnesium, carbon, sulfur, and phosphorus. Nitrogen 2 oxide. This is another oxide of nitrogen. Nitrogen 2 oxide can be prepared by heating a mixture of dilute triosonitrate 5 acid and copper turning. Copper is covered with water and concentrated triosonitrate 5 acid is added, about equal in volume to the water. Vigorous effervescence occurs and the flask is filled with brown fumes. Physical properties of nitrogen 2 oxide. Nitrogen 2 oxide is a colorless and poisonous gas. It is neutral to litmus. It is slightly denser than air. It is almost insoluble in water. Chemical properties of nitrogen 2 oxide. Reaction with oxygen. When nitrogen 2 oxide is exposed to air, it reacts immediately with oxygen to form reddish brown fumes of nitrogen 4 oxide. Reaction with iron 2 tetraisosulfate 6. Nitrogen 2 oxide dissolves readily in iron 2 tetraisosulfate 6 solution, forming a dark brown or black compound, which decomposes again when heated. These two above reactions are two main tests for nitrogen 2 oxide. Reaction with hot metal. Nitrogen 2 oxide reacts with hot metal, which reduces it to nitrogen. Now, in subsequent classes, we are going to be looking at nitrogen cycle and other things concerning nitrogen. Please, if you like our videos, hit the subscribe button. If you have any questions, drop it on the comment section. Thank you. God bless.